Let us see Galileo's observations on mass and weight of freely falling bodies. So what basically it means is freely falling bodies is an object which is dropped from a certain height. So what happens to that particular object? When Galileo, when he dropped two objects of different material and different weights and different masses, let us say, one is a wooden mass and the other is an iron mass. So this is made of iron, this is made of wood. But to his astonishment, he found that both of them fell next to each other. He actually did this particular observation standing on the Tower of Pisa, the Leaning Tower of Pisa, which is in Italy. So he wondered what makes the wooden ball and iron ball, which are having huge difference in mass, fall at the same time on the ground. So that led to many theories. Even Newton built up on these observations, Kepler's laws, and then we got to know about gravitational laws and got to know about the solar system and planetary motion. So assume that we have 10 kg and 1 kg of masses, and 10 kg mass is that of iron, 1 kg mass is that of wood. So this iron ball and wooden ball were dropped from a tower, and we know that the weight of the iron ball is equal to 10 times weight of the wooden ball. Now what happens when weight is much higher? It causes a downward acceleration. Acceleration is nothing but change in velocity over a time. So this acceleration is created by the accelerating force. So what is the accelerating force? Acceleration is created due to certain force. So in a freely falling bodies, this accelerating force is created due to the Earth's gravity. Now the acceleration force is greater by 10 times in case of iron body. Why? Because the weight is greater by 10 times that of wooden ball. Therefore, we see that the accelerating force is higher on iron ball. So even if the mass is heavier, because of this higher force, it is able to move and fall to the earth at the same pace as that of wooden ball. So therefore, we conclude that both the balls fall side by side because they have same acceleration. This acceleration is created by the Earth's pull. The Earth's pull, in other words, we call it as acceleration due to gravity. So the acceleration due to gravity makes these bodies move in the downward direction when you are dropping the bodies from certain height and fall to the ground. So in order to understand the acceleration due to gravity, which is represented as g in the horizontal motion, we represent acceleration as a, whereas here we represent it as g, and which is nothing but meter per second square, the SI units, and it's a vector quantity. Now this acceleration due to gravity g, it was found that it differs from place to place. And the experiments were conducted at Eagle City, Alaska, when an object was dropped, 1 kg mass object from a height, And the known parameters here are time it takes to drop and also the distance or the height from which it is dropped. These two are known parameters. And we can find out from law of motion what is the equation of law of motion, what is the acceleration. So equation of law of motion states s, which is the distance, is ut plus half at square. When a body is dropped from top, u is 0. So with the known t and with the known s, we can find what is a. This a was found and given as 9.8218 meter per second square. Therefore, in Eagle City, Alaska, when 1 kg was dropped with a known time and distance, the g that we obtain is 9.8218 meter per second square. When the same experiment was repeated at a different place, at Panama City, they found that g value is 9.7824. This is meter per second square. It shows that the force of gravitation does differ on different places of Earth because it is measured with respect to center of the Earth, which we will come to know why it happens in the later chapters. So when we see the definition of 1 Newton, definition of force, we know that when exactly 1 kg is dropped, a force of 1 Newton would give an acceleration of 1 meter per second. So from force is equal to mass into acceleration definition, we know that when 1 kg is dropped, a force of 1 Newton would give an acceleration of 1 meter per second square. Now in this case, if the g, acceleration due to gravity, is 9.8218 meter per second square, what does it mean? That means a force of 9.8218 newtons is generated. Means if g is 9.8218 meter per second square, 1 kg on 1 kg of mass gives a force of 9.8218 Newton. And if G is 9.7824 in Panama City, then on 1 kg of mass we get a force of 9.7824 Newton. So this is called the weight of the object. So since weight is nothing but mass into acceleration due to gravity, we know that the weight is mass into acceleration due to gravity. In this case, mass is 1 kg and acceleration due to gravity is this. So we get this is nothing but the weight of the object. The mass of the object is 1 kg, whether it is in Eagle City or whether it is in Panama City, whereas the weight changed because the acceleration due to gravity changed in different places. So, acceleration due to gravity, why does it change? It changes because its position with respect to the center of the earth changes. So, that we will get to know later. So, the main point here is the mass is constant, whereas weight changes based on the location of the object on the earth because g changes. So this is called the weight of the object at different places. But universally accepted acceleration due to gravity value g is equal to 9.8 meter per second square. Because on an average, when it was taken in different places, measured, and then came out with the average, and they found 9.8 is appropriate. So basically, from Galileo's observations, the freely falling bodies, irrespective of the mass, their weight, based on the weight, they will be moving, and the acceleration due to gravity is constant by the earth on all these masses, so they fall at the same time.